How complex can a chair be? Or perhaps, how complex does it have to be? Well, it has to support and be comfortable for a wide range of people with varying heights and weights. It will have to sustain a variety of forces for an extended period of time. And on top of all that, this set is going outside. These are already a lot of design parameters. Unfortunately, a set of chairs can only really garner as much value as the table they sit around, even though their complexity can far exceed it. Because of this, efficiency is key. Streamlining all the processes and batching them together is necessary so that good chairs can be made at a competitive price. It is often said that chair making is one of the most challenging areas in woodworking. All that being said, let's make 8 chairs. Any good chair job will start in one of two places, either the sawmill/timber merchants or the woods. In this case, it was the timber merchants. As I'm building these chairs from Iroko. Iroko is very similar to teak, just easier to come by and at a better price. When looking at boards, the first thing I will do is look for bowing or twisting down the length of the board. I am also looking for checks, shakes, knots, and insect-related defects. The grain direction will also be very important. Luckily, Iroko is mostly straight and without knots, which makes for easy picking. For chairs, I am not looking for exciting grain, as I am prioritizing strength and form, and will not be relying on exciting grain to do the visual heavy lifting. I will always try to find my largest components first, and use the extra space on those boards to find my smaller components. When building a set of chairs, I like to cluster repeated components across all the chairs onto the same or similar boards. For example, all the back legs will have a similar colour across all the chairs, and likewise for the other major features. I prefer this to trying to match each chair within itself. It also has the benefit of being easier to lay out and machine the parts. One more thing you need to account for is the milling allowances. I always will add 5mm to my width and my thickness, and 50mm to the length. If it's for nested patterned components, then I will take the patterns to the merchants and lay them out with chalk then and there. Running boards over the planer and through the thicknesser can lead to tear out if run the wrong way. Sometimes boards will tear out anyway, as the process can be quite violent. When this happens, I choose the best result and go with it. I'm leaving an extra 0.2 to 0.3mm on anyway, which gives me room to hand plane into dimension. I prefer to remove as much waste on the bandsaw where appropriate. The economy on the bandsaw blades is better and can save a lot of time compared to planing off, for example, 10mm. Choosing the grain directions in your parts, you want to align them. If your part's curved, you want to find grain that will mimic that curve if possible. You can see on these prototype legs that that grain is arcing with the back leg. This is desirable. One thing you can do as well is book match your stretchers and the components for a nice mirrored look within the chair. I am not doing this on this set, but for a single chair it would be a nice touch. For example, here on the prototype, I had the opportunity to do it. An efficient way of milling multiple identical parts is to run the bandsaw at the same time as the planer. You mill one face and your first edge, and then cut a strip off on the bandsaw at your extra 5mm milling allowance. And you go back to the planer and you mill a new square edge off the rest of that face. And you repeat this process until you get through your board. Here's an example of me using an offcut which had bigger nested components to make up on my smaller components. It's very important to keep track of all the components, as it can get quite confusing. I'm going to be setting up the spindle moulder now. I couldn't get the correct blades from Whitehill Tooling, the maker of my cutter block. I bought these blanks online and I'm just transferring the lines off a factory Whitehill blade and then grinding down to those lines so that it fit. Once I've ground them down and confirmed they fit, I start putting my edge on them. These are a limited set, so they've got limiters paired with the blades, which sit about 1mm inside that geometry. I bought this block second hand because they're very expensive, and I'm just giving it quick restoration to clean it up so it's good for service. The limited aspect of this block is a safety feature and effectively limits the rate at which the machine can auto-feed your hand into the blades, and then they get the custom polishing as any plain blade would. Tightening the blades fully is easier once it's already in the machine. When positioning this block, you want to get it as low on the spindle as possible and build up on top before you put the nut on. This will reduce the amount of deflection that the block will undergo and increase its rigidity. I need to set the cutter block square to the machine, and I'm going to do this with a hammer and a dial indicator. I can also use the indicator to get the timing of the blades matched. This will ensure that the cutters are balanced and there'll be minimal vibration in the machine, and you'll get a better finish on your surface. The spindle moulder has the potential to be the most versatile machine in woodworking. This one is a Wadkin EP from 1946. If you want to see me rebuild this machine, I will link it at the end of the video. If you've already seen it, it's good to have you back. Jigs and jig making is the foundation for the majority of moulding operations. For this shaping operation, I'm using a pattern on the underside of a blank, referencing the ring fence under the cutter. The majority of the waste is removed on the bandsaw first. Toggle clamps are effective for holding down the parts during moulding. This setup is very good for batch production, as I have 16 back legs to do with 2 moulded sides each. Doing these processes in a batch format eliminates repeated setups and helps bring down the cost. And I'm very aware my extractor isn't doing very much here. During this job, I did buy a new one. On my pattern, there are 2 layout lines that I will need for mortising and other processes later. Before I remove the pattern, I transferred them onto my parts. This ensures consistency. The mortiser is the perfect counterpart to the spindle moulder, as it can cut square-sided mortises, which is the only task that the spindle can't do. This one is a hollow chisel mortiser and has a heavy-duty build and a long lever, which makes very quick work of the hundreds of joints I will need to cut on it. Speaking of mortise and tenons, now to cut tenons on the spindle moulder. By stacking spindle blocks and having a strong, properly built tear-out jig, you can batch out tenons very quickly. On this machine you can set any parameter such as shoulder length, tenon width, and almost any other you can think of. Later on I will demonstrate how far you can push this method. The rest of them are going to be, how do I say it, angled. Here you can see how easily I can achieve perfectly matched joints. I just wanted to talk about how I prepare for jobs with designs and such. This job I am working off an undimensioned design sketch and 2 one-to-one skins. I will avoid using CAD if possible, purely because I don't like it very much. It is a very useful tool and I just prefer this method. I am also running an ash prototype which all of the processes get tested on first. In the prep, I plane and sand the appropriate faces that I can't later. I will also clean the corners of my mortises and chamfer all of the edges. Glue-ups can make or break a job. The stakes are high, so I will do everything in advance to mitigate any issues. This includes a full dry run, where I can hone the method and prepare all of the clamps. Then I am practicing on the prototype before doing that glue-up for each chair. I'm using Type 1-3 and heavy planes are enough to weigh these frames down to ensure they dry level. With every glue up further into the job, the consequences get higher and higher. I knew something was up. Keep going. Like I alluded to earlier, here we are tackling a much more complex set of tenons. They are all angled, and some of them are at compound angles. With the proper jig, this can be accomplished as quickly as the straight ones. Here you can see me cutting them to length, which will be important to get my shoulder length correct later. This is a nice moment as we get to see how it's coming together and how all the joinery is interacting. See the bit I'm going to take off. prep and theory is all the same, only now there are more joints and more pressure to beat the glue's open time. This glue up took 20 minutes, which is quite close. The batons at the back are allowing the clamps to be put in positions that can easily manipulate square. I am using a straight edge, wedges, my heavy planes, and am shifting the clamps around to pull all my joints into level and square. To measure square, you measure the diagonals. I am using small screws that are on the underside of the seat to attach the patterns. Since it's a large squarish shape, I can safely shape it without a jig. After removing the bulk of the waste on the bandsaw, I take it to the spindle moulder. I am making sure to start on end grain and finish on long grain to avoid tear out. To cut the corner to interact with the front leg, I am using an offcut from one of the blanks in a simple stopped setup to make it repeatable.
all I hate.
After moulding the seats, they get shaped to be comfortable and to drain water. The bulk is taken off with a power carving tool. Then I move on to traditional seat carving tools to bring it into shape before sanding. The tools I'm using here are a scorp and a homemade Travis shear, followed by a homemade chair scraper. At this point, space in the shop is becoming an issue and slowing me down. To combat this, I would store them outside during the day if the weather was dry. crest moulding is the same business as the back legs, just a new profile. The backs are panels that match the curve of the crest to provide the comfort, and the gap down the middle provides relief for the spine. They are laminated from 4 pieces of 2.4mm thick Iroko veneer. The bending former is made from a solid oak that has a lot of defects and is not ideal for furniture. That's why I'm using it. West Systems is used at a 5:1 ratio and is held for a minimum of overnight under vacuum pressure. A pair is done at a time, leading to 8 in total, not including the prototype. They can be doubled up, and the curve is slight enough to make the degree change negligible. However, I tried it for one, and the time constraint led to a rush, which is not ideal. I wanted the arms not to extend beyond the front legs, so I made some quarter round arm raisers which are bridle jointed to the front legs, then an oak dowel to attach them to the arms. After making the arm raisers, it's time to mould the arms. I attach the patterns with small screws, being careful to attach them on the underside. Same spindle moulding deal here, only this time, to avoid making another holding jig, I reused the back leg one. It was quite a close match already. It's quite a lot to remove. To attach the arms, I'm using dowels and a screw. The screw allows me to avoid clamps and provide strength also. The dowels add even more strength. This joint will be in shear force, which is what screws are designed for, and the front joint is under compression, and the grain directions ensure short fibres are not being pulled on. The back joint is backed with oak dowels for looks. I reduced the number of dowels from the prototype to the set as I didn't want to remove too much material from the back leg, and I didn't feel like the extra two provided enough strength to justify it. The clamps I'm putting on are applying very little pressure and are just to hold it down until the glue dries. Even though the bridle joint is not mechanical, it is a very tight fit and has very good gluing surfaces, and I trust that it is extremely strong. Here I'm just doing a simple visual check to make sure everything is consistent. Here I'm putting a slot in the crest rails, which will accept the back panels. When talking with the veneer merchants, I had to compromise on the colour of the material for the back. This was because the width that I needed was on the wider end of this material's availability, and that meant a limited choice. That's why I'm using stain to bring the colour closer to the rest of the chairs. I'm aware that eventually this will all be grey many years from now. Although it pales in complexity to the glue-ups prior, due to it being the last, everything is on the line. That being said, it all went very well. The slots that I'm cutting into my oak dowels are to allow the air to escape and avoid a piston-like effect. Clean up for this one wasn't very fun. These are A4 stainless steel brackets that I will be using to hold down the seats to the frame. I milled these slots into them to allow for wood movement to occur. The effect will take place on the internal gap of the chair, closing and opening. The front legs are protected from being pushed on, and there are a total of 6 brackets for each chair, which locks the seats onto the chair, making the whole assembly very strong. These chairs are going outside on a patio. To protect them from water and splintering, I made skid pads from HDPE, which is completely water resistant and won't scratch the patio. I'm using an old dull saw blade to cut it, as I don't want to ruin a new one. Since wood is basically lots of straws set in lignin, it will draw up moisture very quickly from the bottom of the legs. The skid pads will prevent this. It won't really. My process for finishing these chairs goes as such. Everything is sanded to 240 grit prior, and then I will clean them with methylated spirits. Once that is done, I apply one liberal coat of varnish and give it a day to dry. After the first coat, I then sand it again with 240, but only lightly to level the surface. I then clean it again with methylated spirits. The second coat is applied much more sparsely, and I'm focusing on a very even coverage and making sure all my brush strokes align with the grain direction. For this coat, it being even is key. After that, on the high wear areas such as the seat, arms and crest and the back, I applied one more coat. When attaching the skids, I used a generous pilot hole to minimise the risk of splits forming. As the screws are under very little load, I felt the loss of strength was not a problem here. I also sealed the grain under the pads, and the A4 stainless steel marine screws are put in with beeswax to minimise seeping. And with that, the chairs are finished. So after seeing the process, and for myself experiencing it, how complex did it have to be? I found these chairs to be on par with the Windsor chair that I made in a previous video, though for very different reasons. This job was a lot of fun to build, and definitely a challenge. All in all, success. These chairs will be united with the huge Iroko table that was also built on this channel. Thank you everyone who watches. We have recently reached 1,000 subscribers, which is very exciting. If you have any questions about my processes, machines, or anything related to chair making and furniture, feel free to ask me in the comments. I have another huge table job on the way, so stay tuned for that. Cheers.